Hello everyone, welcome back to the channel. My name is Danny, and today I wanted to talk to you about a topic in Rust called static versus dynamic dispatch, aka polymorphism. So without further ado, let's get right into it. Alright, so I already created a new project here called trait object, and we're gonna go ahead and demonstrate this using very simple struct called dog and cat. Okay, so let's start with struct dog, and we'll give it a breed name with string, an own string, and also let's do a breed, and let's give them a name as well. All right, so the same thing with the cat. We'll do the same struct with breed, string, and name, string. All right, so as you can see now, we have two types of animals. One is called dog and one is called cat. So what we're gonna do next is we're gonna implement some methods on these two structs. So one's gonna be for dog, and we'll make a new function here called bark, taking a self. So it's gonna be a method. It's gonna return a string. Let's do wolf. Convert that to a string. All right. And then for cat, we're gonna do meow, take in the self instance, return a string, meow. Okay, so now we have two structs with two methods, one method on each struct. So as you know, let's go ahead and start creating some instances. Let's do dog1 equal dog. Let's do breed. Let's do German Shepherd. And also name. Let's do Fletcher. Make sure you convert that to a string. Same here. Alright, so now let's do one for cat. Siamese. And let's do name. Let's do Mimi. Okay, so now we have two struct objects. One is dog and one is cat. Let's go ahead and let's do a print line. Dog1. Let's get it to bark. And another one for the cat. Let's get it to meow. Okay. Let's see what we have so far. Make sure that the code is working. We're gonna go ahead and run this. It looks good. Okay. Alright, so everything is working just fine so far. But let's make sure that we have a derive debug trait on here, so that we can print it out later on. Same for the cat. Okay, so now let's say you are a pet shop and you wanted to have a way to describe each one of the pets that you have so that your customer can know exactly what breed and what's the name of the pet that you have available for them. How would you do that? So let's say you want to make a function here called list pet, and you want to return a string. Basically what this is, it's going to be you're going to want to introduce each one of your pets that you have in inventory, so to speak, right? So we're going to say my name is, and I am a breed of, and we're gonna pass in the pet breed and the pet name. Okay, very simple. And we're going to return that as a string. Okay, so what are we passing in here? We're going to pass in pet. But what is a pet, right? So I could write two separate functions, one list pet for a dog and one list pet for a cat, and they would basically format the string the same way, however slightly different for each one. Or I could do a list pet and I could take in a struct, and I could do a match case where I would say, oh, if the pet is a dog, then we'll do this. If the pet is a cat, we'll do this. But that's very redundant. So what I could do instead, of course, is use a type generic, right? So we could do a type T here, and the pet that we pass in is going to be of type T. Now, of course, if we do it like this, it's not enough. The code is not going to compile, simply because the compiler doesn't understand what type of T it is. I mean, we could pass in an I32, a string, we could pass in anything, and there's no way that the compiler would know, would be able to guarantee that we would have these two fields within the type T. So the next step to take is to pass in a trait bound, and it's going to be, we're going to create a trait called pet, right? And we're going to make sure that whatever type we pass in here is going to have to implement that trait, excuse me. So what we're going to do is go back, and we're going to create that trait right now. So let's do trait pet, and we're going to have to create an interface, basically a function, a signature that's going to be required by every single struct that implement this trait to adopt to their own method, pretty much. So let's do one called introduce. Okay, that's going to be the struct, and we're going to take in the type, take in a self, and return a string. Okay, so if we're going to do that, then we don't need to do this actually. We're just going to say pet dot introduce, and that's that. Okay, and it's going to return a string. So now we have to implement the trait pet for our dog and our cat struct. So we're going to say fn introduce self string. Okay, and we're going to send a format macro. My name is, and I am a breed of, just like that, and it's going to be self dot name and self dot breed. Okay, and we'll return that, and everything looks good. So now we have a function list pet that the vendor, that the pet shop can use, that will take in a generic type T that implement the pet trait, and it's going to return a string by calling this method introduce that every single struct is guaranteed by the compiler to have within their own implementation. So let's try to do that now. Let's go with dog1. Actually, no, list pet, and we're going to pass in dog1. Oh, by the way, we might want to make this, we just want to borrow. We don't want to move the ownership into the function. List pet, not implement for dog. Introduce. List pet type string. Okay, just like that. Sorry about that. And then we're also going to pass in cat. And make sure we're going to print this as well. What's going on here? It's implemented for dog, but not for cat. It is implemented. Oh, I didn't do one for cat. I'm sorry. Okay. right, it's going to be the same exact thing. All right, there it is. So now we have the, we're going to do a list pets for the dog and for the cat, and we're going to make sure to print it out. Same here. All right, let's see if that works. Okay, so now the two methods are working. My name is Fletcher, and I am a breed of German Shepherd, and then my name is Mimi, and I am a breed of Siamese. So now everything looks great, okay? But as you can see, this is actually what's called static dispatch. So dispatch just means how a function is invoked. And basically, it refers to how the compiler is able to resolve the function or the method. So what happens with this function is, because it's statically dispatch, the compiler is actually going to create two separate functions just like this, except for they're going to pass in the explicit type of cat and dog for each one. So it's going to be a list pets of dog and it's going to be a list pets of cat. And they're just going to use those two. And they already know exactly the size of the type that's being passed into as an argument. And that's why it's a statically dispatch function. And so what that means is it's a lot faster, and the compiler can optimize the function a lot better. However, it's not as flexible as the dynamic dispatch method that we're going to show you in just a little bit here. But that's basically how it works under the hood. It takes a generic type, and the compiler is going to basically, they're not even going to have this. The compiler, by the time the code is compiled, this is going to be gone. And it's basically going to be a list pets of dog and a list pets of cat. Two concrete type being listed out explicitly with the new functions that's being compiled to. So let's go ahead and we're going to change this. We're going to name it static so that we know that this is the static method that we are testing on. And so we're going to create a new one now. So now let's say if I don't want to go and go in each individual instance of dog and cats and, you know, crocodile and snakes and alligators, and then call a method on each one of them. What I wanted to do is keep them all in a container or an array for the pet shop, and whenever the time comes, I can just loop over each individual pet, and each one of them is going to call that method on their own instance. That would be great, right? However, if you try to do it like that right now, let's give it a try. Let's say let shop equal a vector of dog and cat. If we try to do that now, as you can see, the compiler's not happy because it's not the same types, mismatched types, dogs and cats. Vector can only accept types of the same types, so we can't do that. So, but however, what we can do is create an abstraction to where we tell the compiler, look, I want to place inside of my vector, what I want to place inside is, instead of just random types, I'm gonna place inside of this basket dynamic, and I'm gonna name it let's see, dynamic pet. So basically what I'm telling the compiler is, hey, this is gonna be a vector of any type that implements the pet trait. So what I would do with that, what that means is dogs and cat, as you can see now, the compiler is happy because it's, as long as it satisfies the condition that they implement the pet trait, everything is all good, right? So now I'm allowed to do that. However, if I did that, and if I say for pet in shop, right, and I wanted to use the describe method on each one of those pets, it's not going to be happy because the describe method has to take in a pet, a generic type T, and it has to know exactly. So hold on, actually no. Oh, I'm sorry. That's not how you do that. List pets static pet. Yeah. So if I did it like that, it would say it doesn't know the size of the argument. Removing, okay, yeah. So if I did that, The trait pound is not satisfied. List pet static. Oh, okay, there it is. So now it says it doesn't know the size for the values of type dynamic pet cannot be known at compilation time. The trait size is not implemented for dynamic pet. So basically what happens is when you pass in a dynamic pet, this is called a trait object. So what this is actually a Y pointer that's going to point to two different things. One is going to point to the data. It's going to be the struct of whichever one it is, the dog or the cat, the struct itself, pretty much this. And then the next pointer is going to be called a V table, and it's going to point to the function, the method that's being implemented. So it's going to be pointing to this right here, right? However, as you can see, that's a pointer in direction, and that can only be resolved at runtime, not at compilation time. So therefore, now it's dynamic dispatch. So this won't work. What we're gonna have to do is create a new method for that, or a new function for that. We're gonna say list pet dynamic, and we're gonna take in pet, and the same thing as before. We're gonna return a string, and it's gonna be the same thing, pet.introduce. But how are we gonna pass in the pet? So the pet is gonna be passed in like this. Dynamic pet, just like that, right? So now we're passing in a trait object. So when you see this, think trait object, and when you think of trait object, think of pointers, right? It's a Y pointer, so it's going to be 2 pointers usually, right? And we know the size of the pointer during compilation time because each pointer is around what, 4 or 8 bytes. However, what we don't know is how big or the objects or the function or the methods that the pointers are pointing to. We don't know that at compilation time. We only know that during runtime. So now what we can do is when we loop through the shop for each individual pet trait object, what we can say is list pet dynamic, and we'll pass in the pet just like that. And now that will work. And let's give that a try. Oh, we gotta print it. Okay. And as you can see, it printed out twice. Once for this and once for this. So it's working. So as you can see, that's the difference between static dispatch and dynamic dispatch. Static dispatch, basically you know the size of the arguments at compilation time, and it's pointed straight to the stack, so it can create that function call right away. It can optimize the compiler can optimize the function. It basically create duplicates of that function for each individual concrete type that's being passed in. However, with the dynamic dispatch, the compiler doesn't know how big is the arguments being passed in. All it knows is, okay, I see 2 pointers. I know exactly how big the pointers are. I don't know what the object being pointed at is gonna be how big it is. So there's another way we can, if you wanted to basically take ownership of each trait object, you can also wrap it inside of a box, right? Box basically is, it's gonna create a new object on the heap, and it's gonna just point to it. So what we could do now is, let's say, let shop own, and it's gonna be a vector of box, right? And it's gonna be, each box is gonna be the same thing, dynamic pet, just like that. And we'll have to create some new objects now on the heap. So we're gonna create dog2 and cat2, but we're gonna use the box new associated function instead, and it's gonna be dog, right? And it's gonna be name, breed, it's gonna be, let's do pitbull, and name is gonna be lucky, okay? And then we're gonna do another one. Let's see right here, okay? Box new for cat. The breed is gonna be, what's another breed of cat besides Siamese? Ragdoll. Okay, and then name is gonna be Kevin. That's my cat's name, right? Let's see, what's the problem here? Mismatch type, dynamic pet. Oh, yeah. Oh, don't forget to convert it to string, because as of now it's a string slice. Okay, and then we're gonna loop through that for pet in shop own. Okay, we're gonna do the same thing. It's gonna be let's pet. Oh no, we're gonna do pet dot as ref, right? That's how we get the references outside of the box. We open the box, unbox it, and then whatever's inside of that, and we're gonna say describe. Scope, describe, introduce, I'm sorry. Introduce. Okay, let's see if that works. Oh, make sure we print it out. Okay, so as you can see, Lucky and Kevin, breed a pit bull and a breed a ragdoll. Everything's working. So as you can see, that's the difference between static and dynamic dispatch, and each one of them has their own place. One is more flexible, but it's a little bit slower. The other one, the static dispatch, is a lot more convenient and it's optimized better by the compiler. However, it's not as flexible. But basically, it's just a layer of abstraction on top of the generic types and the functionalities of each trait that a struct has to implement. And they basically group by that category instead of just the traditional things that we think of. And I find that very fascinating, actually. And yeah, so I hope that helps you guys. If you got any question, let me know. Comment, leave me a like, a thumbs up, and hope you guys enjoy that, and take care of yourself. I'll see you next time.